Hello everyone, myself Sonu. Today I'm going to show you how to create and configure the MCP server in .NET and how to configure it in the Claude.ai desktop application. As well as we will see how we can configure the MCP servers in GitHub Copilot. So for that, let me first show you the Claude.ai application. So in the Claude.ai application, this is my desktop application. If you see this tools, currently only the web search tool is configured here. That means whenever I ask a question which is out of the context or which is not pre-trained, it is going to connect to the internet and search on the web for the data. So for example, what is the weather alerts in CA, that is California? Now you can see the result generated from the web search result. As you see, it made a web search on different websites and has generated this result. Now we will see how we can create an MCP server. For that, I am following the demo given in the model context protocol.io website. There is a quick start example for server developers. So in this, we will be using the .NET, that is C# language for building this application. So we should have the .NET 8 or higher version installed. So in my machine, I have the .NET 9 installed. So I'm going to use this. So I'm just copying this command and trying this in the command terminal at desktop. So let's go and create the console application. After this console application is created, let me open this in VS Code. We need to install a couple of packages. So let's install these packages. One is the model context protocol package, and the second one is the Microsoft extensions hosting package. After these packages installed, we need to update the code to use this model context protocol service and the HTTP client service to connect or to call these APIs. So for that, I'm just copying this code into the program.cs. So let's open this program.cs. So here you can see we are configuring this MCP server as a service and also creating an HTTP client as a singleton service, because we have to make the HTTP service to call the APIs. So we are going to make a call to this API, and this API is going to give you the weather informations for US. And if I check this URL, you can see there are different API endpoints for giving the weather alerts, the active weather alerts, and many other API endpoints. So this API endpoint, so this is for the weather forecast, which is accepting the latitude and longitude information. So we are going to make a request to this API endpoints to get the weather information. As you see inside this application, we are configuring this base URL as the HTTP client's base URL, and then we will create couple of utility classes. The first utility class which we are going to create now, we are going to create that utility classes. For that, let's go to this, and you can see there is an HTTP client class required that is going to make the HTTP request to the API using the HTTP client and returns the data in the JSON document format. So I'm going to create a new class inside this project with this name, and this, then copy this code into this. As you can see, this method is just makes an HTTP request using the HTTP client and then returns the result in a JSON document format. We also need to create a weather tools class, and this weather tools class is an MCP server tool type, and inside this class we have two methods. One is the get alerts and the second one is the get forecast. So the first method is used to get the weather alerts from the API, and second one is to get the weather forecast for a particular location. So both the methods are marked with a MCP server tool. So it's going to mark that this is a API tool method or a MCP tool method, and this is the description for this methods. So the descriptions helps the LLM to understand what is the usage of this particular function, and it helps the LLM to select the appropriate function based on the prompt. So now we are going to create this class. So let's go and create this class and then copy this code into that. So after this, we have to run this application. I'm just opening this command terminal and use .NET run command to run this application. Now you can see this application is now running. So once the application is started, we need to configure this MCP server inside our LLM application. So here I have this Claude. So I need to configure this into this application. So how to configure that for the Claude? For that we need to create the Claude desktop config JSON file. So inside this app data Claude folder. So we can use this command to create this file and open this file inside the VS Code. So let's copy this command and then go to the command terminal and run this. So it opens this file in the VS Code. So here we can copy the JSON configuration. So this is the configuration for the MCP servers. So let's copy that into. So this configuration tells that there is a tool called weather, or there is an MCP server called weather, and it is a .NET application. So we are going to run this application using the .NET command, and .NET run command is going to be executed, and here we need to specify the path of this project. So we can get this path of this project from here. I'm just copy pasting this path here, but we need to provide a double slash since we are running it on Windows. So I have updated the path. So now this file we have to uh, configure inside our Claude. So let's verify whether this file is placed in the correct location. So let's go into the C drive, users, and then app data. This, and we need to verify Claude. And here you can see this Claude desktop config is there. So if you open this in Notepad, you will see that project configuration here. So now we can verify whether this is configured inside our Claude desktop application. So if your Claude application is already running, then you cannot see that tool here. So to ensure that tool is correctly configured within this application, we need to restart the application. So if it is already running, so I'm just going to quit this application and then relaunch. So now we can see the application is relaunching, and now let's check the tools. As you can see, there is a weather tool which is currently disabled, so I can just enable all the functions. So you can go and enable whatever tools or functions you have, so only that selected methods you can enable. So we have two functions or two tools within this MCP server, that is get alerts and get forecast. So now I'm going to make a request to get the weather alerts for California. So what is the weather alerts for the state California? Now I'm making a request. You saw that previously it was connecting to internet and doing a web search, but now you can see it is invoking the get alerts tool and passing this CA, as that is a California, as a parameter. So because if you look into this API is expecting, the alerts API is expecting the state name as an argument, so that we are passing to this application. So that is part of the URL. As you see inside this weather tools, here we need to pass the state value, and the state value should be one of this, right? So now this is going to be the response, and you can see the result which is generated, right? Now suppose if I have to check the weather forecast for a different state, so I can just go and make a new request. So instead of CA, let me try some other state value. Maybe I can try this FL, which is another state. So let's make a request for FL. So it's saying there is no active alerts for Florida. So let's try a different one. And let's go MI. And you can see some information is coming. So Michigan, you can see, and this is what the alerts information. Similarly, if I have to get the weather forecast for a particular location, I can ask what is the weather forecast for the location, and we have to specify the latitude and longitude. As you see here, this method is expecting the latitude and longitude as arguments or as parameters. So I'm using this website to get the latitude and longitude of a particular location. So I can specify California. Oops. Okay, so this is the latitude and longitude for California. Let me copy this into here, and also I can specify the longitude. So I'm specifying this. Now you can see it's going to make a request for get weather forecast tool. So it's invoking the get weather or get forecast tool and passing this latitude and longitude information, and you can see it's receiving the result in a JSON format, but using this JSON format it is going to generate this response. So now you can see, to get the real-time data from a backend API, I have used the MCP server. So in my MCP server, uh, my MCP server is created with .NET and it is running in background. And whenever I make a request in the LLM tool or LLM application, it's connecting to the MCP server and selecting the appropriate tool from that MCP server and invoking that backend API to get the real-time data. So that is the benefit of using the MCP servers in LLM application or generative AI applications. So far we have seen how to create and configure an MCP server into an LLM application. So now we will see how we can use the MCP server configuration, or how we can configure the MCP servers inside our GitHub Copilot. So if you look into GitHub Copilot, it is supporting this agent mode. And if you go into the agent mode, you can see multiple models are now supporting this agent mode. And this agent mode, you will be able to see a list of tools which are already configured with GitHub Copilot. So if you click on this, you will be able to see there are some built-in tools which are already configured, and you can see there is one MCP server which is already configured in our Claude application, because we have this Claude Sonnet model configured inside our GitHub Copilot. So I can switch to some other model also, and we can also see the similar list of built-in tools here. As you see here, this is the pre-built set of tools configured here, and I can see a set of built-in tools that is going to fetch the content from a web page. That means this fetch is one of the uh, built-in tool that is helping us to fetch the content from the web page. For example, if I go and ask fetch the content from, and then I'm giving a web page URL. So I have this GitHub profile. So this is my GitHub profile, which is containing the information about me. So I'm giving this URL here. Let's see whether it is able to fetch or not. So we can see it's asking fetch the web page. So continue, and it is fetching the informations. You can see the summary of the content is coming here. So the name, bio, location, company, and so on. So you can see all these informations from that page is appearing here. But if I go and remove this built-in tools. Okay, you can also see there are tools from GitHub Copilot for Azure, then weather, the MCP server for weather, which is configured, and you can also see there are some other tools for MS SQL, Python, Jupyter, etc., etc. So I'm just removing all these from here and then asking the same question here. That means I'm not going to use any tool now. Let's see what it says. So it's saying, sorry, I cannot assist with that. That means it is not able to go and fetch the data, because previously it was using a pre-configured fetch tool to fetch the data from the external website. So now I'm going to show you an example how to create our own MCP tool, or how to configure an MCP server or MCP tool inside the GitHub Copilot. So for that, there is a built-in documentation available in GitHub Docs, how we can extend the Copilot chat with the MCP. So for that, we need to have access to the Copilot, and we should have Visual Studio Code version 1.99 or later version. And so we need to configure a script that is specifying the details of the MCP servers. So there are two things we can do, or two ways we can configure. Inside a specific project, we can configure the MCP server. So that means inside the project folder, we need to create a .vs code folder. Inside that, we can create a mcp.json and specify the MCP server configurations in that. So this MCP server configuration is only applicable to that particular repository or that particular project. But benefit is, whenever you copy this project to any other machine, or when you share this project with any other user, they can also use this MCP server. But it is also possible that you can configure the MCP servers in a single location and make it applicable for all the projects within your machine, but it cannot be shared with the others. So for that, you need to configure the MCP server inside the settings.json of your VS Code. So inside the VS Code, we have the settings.json for configuring the extensions and other functionalities of VS Code. So if you are configuring the MCP servers in the settings.json, it is applicable to all the projects or all the repositories within your machine. Whenever you use the VS Code, it is applicable. But when you copy the project to a different machine or share the project with a different user, this MCP server configuration will not go with that. So if you are planning to use this MCP server configurations within a specific project only, and you want to share it with other machines or other users, use this approach. Means create a .vs code folder and create an mcp.json file inside this. Or if you want to configure the MCP server for all the projects within your machine only, then you can configure this inside the settings.json file of the VS Code. So I'll be showing this with the specific repository example. That means we'll use a .vs code and MCP file. So for that, we need to create this particular file that is inside our project. Suppose if this is the solution, I can go and create a new, you can take any project. So this is my previous project which is already open in VS Code. So I can create this file that is mcp.json inside this .vs code, and inside this we need to copy paste this configuration. So it depends on your MCP server configuration. The configuration parameters will be different, but here you can see this is the configuration for a fetch server. So as you can see, this is for the fetch. As you can see, this is requesting, or this is requiring a prompt string. Means this uh, MCP server is accepting a prompt string, and we need to start this MCP server. In our previous example, we have used .NET as the command to start the MCP server, but here the MCP server we are starting with the UVX command. So UVX is a command line tool which need to be installed in your machine. If it is not installed, you can install it in your machine. So install UVX. So you can try this documentation. So here it's clearly mentions how we can install the UV command line tool. So here either you can use the PowerShell command for that, or some other approaches like the PyPI means pip command, or homebrew, winget, scoop, docker, GitHub releases, etc. So if you look into this, I have used this winget option to install this in my machine, so it will automatically configure this UV inside our Windows machine. So since I have already configured this, I don't need to install this again. So I need to first start the server. So here you will see a start button just on top of this fetch server name. So the server's name is the fetch, which can be started explicitly. As you can click, and you can see it is running now. So this is the parameter which is required to start the server. And now if you go back to your VS Code, you can go and check the tools. So I have disabled all these tools, and now you can see there is a new MCP server configured, that is the fetch. Okay, so the built-in fetch is not used now. You can see I have unselected this built-in fetch, and instead of that I have configured my own MCP server, that is fetch. So now I can try the same prompt, like fetch the content from the web URL. I can take this URL and run this. You can see it's now using the tool or MCP server to execute this operation. So run the fetch from the fetch MCP server, and when I say continue, it's going to execute that action, and it is now extracting the informations from that web page. So if I go and disable or unselect this, this is the MCP server I have unselected. Now if I try this again, so this okay, this is already in the response. So let me clear out and see, I cannot directly fetch the content from the external websites. So if I use this tool, it is able to go and fetch this data from this external website. So we need to create the MCP server and configure it within our GitHub Copilot. So currently I have configured this using this mcp.json specific to this particular project. We have already created one MCP server application for the weather tools, which is providing the get alerts as well as get forecast tools. Now we will see how we can configure this inside our GitHub Copilot. Since we have already configured this in the Claude desktop, it is appearing here as a tool, as you can see, the MCP server. But what I am doing, I just unselected these tools like MCP server fetch, MCP server weather, and all the other tools I have unselected. Now I'm going to ask the same question, that is this question, which is asking for the weather forecast for a particular location. So let's see. I'm going to paste this prompt, and you can see the response from this GitHub Copilot that I don't have access to the real-time weather data or external API directly. But now, since we have this application ready and we know how to configure this MCP servers in GitHub Copilot, I use the same approach to configure this tool or this MCP server. So we already have this mcp.json file. So what I do is I will open this mcp.json and add a second tool. So I'll give the name as US weather. So US weather is the tool, and I can specify the parameters like since it is a .NET application, I can say .NET, and it takes some arguments. And what we can do is these arguments we can just copy from the previous configuration file, that is the cloud. For Claude desktop we have already specified this parameters. The same we can copy, that is this arguments we can copy as it is here. I don't need this environment variables, so just put this. So as you can see, this is now configured. So this is the command.NET, and we are going to use this application as a MCP server. Now what we need to do is we need to start this MCP server. You can see the US weather is the MCP server name, and let's verify whether it is visible inside our GitHub Copilot. So let's go and search for that, and you can see here there is an MCP server, that is US weather, is now appearing, and you can also see both the methods or both the tools are available here. So what I can do is I'll try this particular prompt inside my GitHub Copilot. Let's try this. So instead of saying I don't know how to access the external API, it's now use this tool get forecast from the US weather MCP server, and this is going to be the parameters for that. And when I run this, it's going to give the weather informations for that particular location. So similarly, we can also ask what is the weather alert for the state, for the CA state. Now I can see the state CA will go as a parameter, and it's executing the get alerts tool from the MCP server, and you can see the response here. So this is how we create and configure the MCP servers inside the GitHub Copilot. Thank you.